Okay, so for question 5, it's talking about how to measure the specific heat capacity of water. Okay, so they've given you a list of equipment. So when we're going to describe an investigation, we're not going to get any marks for talking about equipment that we're going to use to make the measure the quantities, right? Okay, I think maybe the kind of most useful thing to do here is just think about, okay, what's the energy in here, right? How are we putting energy into the water, and that water is getting heated up, right? So that's Q, right? So we're heating the water up by doing the power, which is V times I, times by the time that the heat is in the water for. Now, actually, they've told us here that that's going to be 50 watts, right? Okay, so that's just power times time to calculate the energy in, right? And then Q is equal to M times by C times by delta T, right? Where that's big T, right? Okay, so what have we got to do here then, right? Well, the first thing that we've got to do is we've got to measure the amount of time, okay? So you could do this for a fixed amount of time, like, you could say turn the heater on for 10 minutes, for example, okay? Or you could do it the other way, because we're going to have to measure the temperature increase, right? So we need to measure the temperature at the start and the temperature at the end. Okay, the other way that we could do it is we could say, okay, I'm going to time how long it takes for the temperature to raise by 20 degrees C, something like that, okay? And obviously you're going to talk about using a thermometer for delta big T, and you're going to talk about using the stopwatch to measure small t. Okay, but because that's given to you in the question already, you're not going to get any extra marks for that. Same, it's given us the balance, and we're going to use the balance to measure M. Okay, so which is the mass, obviously. But then we need a bit more detail for that because it's the specific heat capacity of water, right? Okay, so what might that look like? It might be, taking a beaker and putting that on the balance, okay, and noting down the mass, and then filling it up with water and noting the new mass, okay, and then doing the full beaker minus the empty beaker to find the mass of the water in the beaker, okay? And then once we've got all of this information, we're going to work out the energy input by doing the power, which is 50 watts, times by the time that we timed it for. And then we know that that is going to be equal to the MC delta T, okay? Which means that to find out C, that you'd actually be doing P times by T, okay, divided by M times by delta T, okay? And I think that is all that you need to score all the marks there. And there are, some alternative methods that you could use, like you can measure the temperature against time, and you could use that to find the gradient of this graph, okay, and substitute that into the equation as delta T over T, okay, but to score the 5 marks, then everything that we've just been through will allow you to do that. All right, so then it's asking us to calculate the different problem, but now it's asking us to calculate the amount of energy transferred from the boiler. Okay, it's given us 75 kilograms, so that's our M. Okay, it's given us the starting temperature, the initial temperature, and the final temperature, so that allows us to calculate our delta T. All right, and they've also given you the C there. Okay, so we're just going to use E equals MC delta T. Okay, the mass is 75. Okay, the C is 4,200. Okay, and then the change in temperature is 49. Okay, and if you put all of that into a calculator, then you get 15,435,000, like that. But again, we need to look back at the question. That's to two significant figures, that's to two significant figures. You can either say that that's to two significant figures or four significant figures, but it doesn't matter, because we're going to give our answer to the least number of significant figures of the input data, which is 15 million in this case. And of course you can also put that in standard form as 1.5 times by 10 to the 7 joules.